Look at a YouTube page. It looks like one screen from one place. It isn't. It's 5 completely separate services, and none of them are even allowed to see each other's data. The video, your account, the recommendations, the comments, the view count. 5 services, each with its own database. 5 databases, pretending to be one page. So how does YouTube pull that off? A pattern called API composition. And the easiest way in is a restaurant. Picture yourself in a restaurant. You order a full meal, a starter, a main, and a dessert. You don't get up and walk into the kitchen. You don't hunt down the grill cook, then the salad station, then the pastry chef yourself. You talk to one person, the waiter. The waiter takes your one order, walks back, and visits each station. The grill, the salad bar, the dessert counter. Each station makes its part. The waiter gathers it all onto one tray and brings you back one complete meal. You asked once. You got one plate. You never saw the kitchen. That waiter is API composition. Back to real systems. We've gone database per service. Every service owns its own database. Order, user, payment, product, all separate. And that's a good thing. It keeps everything clean and independent. But now build one simple screen, an order details page. It needs 4 things: the order ID, the customer's name, the product name, and the payment status. Except, where does that data actually live? The order ID is in the order database, the name in the user database, the product in the product database, the status in the payment database. 4 fields, 4 separate databases, none of them able to talk to each other. This used to be nothing. One shared database, one query. Select, join users, join payments, join products. The database stitched it together for you. But split the databases and that join dies. The tables don't even live on the same machine. The trick we leaned on for years, gone. Here's the idea, and it's beautifully simple. If we can't join the data in the database, we join it in the application instead. We add one component whose only job is to collect data from several services and combine it into one response. We call it the API composer, the aggregator, the waiter. Now the picture is clean. The browser only ever talks to the composer. It never touches the services directly. The client asks once. The composer does all the running around, just like the waiter and the kitchen. Let's watch exactly what happens when that order details page loads. The browser sends one request. Get order-details 101. Off it goes to the composer. Step 1. The composer calls the order service. It answers. Order 101 belongs to user 10 for product 50. Now the composer knows who and what to ask about next. Step 2. It calls the user service. Who's user 10? The answer comes back. John. Step 3. It asks the product service. What's product 50? An iPhone. Step 4. It calls the payment service for the status. Paid. Now the composer has all 4 pieces. It merges them into one clean response. Order 101. Customer John. Product iPhone. Status paid. That single response goes back to the browser and the page renders. The user never knew 4 services were involved. The waiter just set down one finished plate. Fair question. Why not skip the composer and let the browser call all 4 services itself? Because it gets ugly fast. Chatty. That's 4 public calls on every single load, often far more. Coupled, your front end now has to know every backend service. And insecure, you've opened your internal services straight to the public internet. The composer keeps all that mess on the backend, where it belongs. And it buys you 3 things. It's simple, just call services and combine. It's always fresh. Every request reads live data, nothing stale. And it's easy to reason about. One path you can follow. Dashboards, order pages, profile screens, admin panels. Any fresh aggregated view at sane traffic, this is all you need. But you knew a but was coming. API composition has a catch. And it only shows up when you get popular. At low traffic, it's beautiful. The waiter strolls to 4 stations. But now your page is getting 10,000 requests a second. And every one of those fans out into 4 service calls. 10,000 requests becomes 40,000 internal calls every second. Latency climbs. The network congests. More calls, more chances to fail. And that little composer in the middle? It's now the bottleneck, the single point everything squeezes through. The waiter is drowning. It gets worse with one specific trap, and every engineer should know its name. The N+1 problem. Show a list of 100 orders. One call gets the list, that's the one. But each of the 100 needs a customer name and a payment status. That's 200 more calls. One page, hundreds of queries. So, API composition fixes the headache, database per service created. It combines data from many services into one response without ever going back to a shared database. We just hire a waiter. For most situations, that's the right answer. Simple, fresh, easy to understand. But at scale, we saw the cracks. A pile of calls per request, climbing latency, a straining composer, and N+1 the moment you show a list. So here's the question that takes us further. What if we didn't do all this running around on every request? What if we pre-built those combined views ahead of time, ready to serve instantly? What if we optimized reads completely separately from writes? That's exactly what the next pattern is built for. CQRS, Command Query Responsibility Segregation. The pattern for heavy, complex reads at massive scale. If this made API composition click, subscribe. We go deep on the stuff that actually matters. See you in the next one.